it's not necessarily the size of the team. I believe it's whether everyone believes that this is a problem worth solving.
Welcome back, everybody, to the next episode of Continuous Delivery Officers, where we delve into the topic of modern software delivery. I'm your host, Tony Kelly, and I'm joined by our regulars, our field CTO, Mr. Bob Walker, and our director of DevRel, Mr. Steve Fenton. Before we jump in, I'll do a little bit of an intro. The question we're going to look at this week is architecture, but on last week's episode, we had a question that popped up. So before we jump into that, let's do the courtesy of answering that question and maybe spend a couple of minutes on that. So last week's episode was all around branching strategies, the different opinions and things that happen in that space, I said. And we had a question from Madhead UK. And the question was, isn't this completely reliant on the size of the team's project itself in terms of maturity? There's a lot more, but that's the general gist of the question of, like, does your branching strategy depend on all of those things? Guessing the answer in a nutshell is going to be yes, or it depends. But let's open it up to Steve. You can kick us off.
Yeah, I think in general, yes. I always say this: no matter what anyone is talking about, and no matter what book you're reading, you are the closest to what is going on in your team and your organization. So you're going to know better than any expert out there what's going on in your company and what to apply. Having said that, Git flow is still highly unlikely to be the answer because of the circumstances in which it was created, right? It's solving problems you don't have. And you'll get all of the compromises, because in order to do this massive scale, there are lots of compromises about things that you would have liked to have done, but you just can't do at that scale. You'll be getting all of the compromises, and there'll be no benefit. That's my short take on it. Bob, what do you think?
I like that you mentioned that every time you see something like this or you see a book like this, naturally you're always going to have some sort of pushback on something like that. And by their very nature, if you go to, let's say, a consultant, or you bring someone in and they say, oh, you need to adopt X, they're going to be whole hard into something like that because they have to be. I mean, that's part of their business. That's part of their shtick. So obviously, take anything you read, take anything you hear on the internet with a grain of salt. Now, that being said, so let's talk a little bit about this team size. I thought that was a really good question. So the vast majority of our R&D staff, we have close to 100 of them, if not more, work on Octopus Deploy, the product itself. And we have multiple teams working on the same Git repo, and we use trunk-based development. So it's not necessarily the size of the team. I believe it's whether everyone believes that this is a problem worth solving, and it's about selling the team on the solution and on the problem itself, and making sure that they're happy that, yes, this is the solution going forward. And they can see the clear benefit as to whether or not to change. So the size of the team really means, how many people do I have to sell on this solution? How many ducks do I have to get in a row? How many cats I have to herd to get everyone on board with something along those lines? And we talked about this a bit last week, where everyone really has to be on board with this approach, because you can't have one team or a handful of individuals or one individual just going off and doing whatever they want, because it's going to completely cause a breakdown in the system. So yes, there's that. Now, when it comes to the maturity level, that's also a really interesting question, because I think there's a bit of a conversation around that as well, because yes, you do need to have a bit of maturity in terms of your build processes, your deployment processes, whether or not you're using feature toggles. That does indicate a degree of maturity. So someone who is just fresh out of college, who doesn't have a whole lot of experience in this particular area, probably is going to struggle a little bit with these things. But again, every team's going to have the senior developers, and then they're going to have the junior developers, and you're going to have the quote unquote regular developers and mid developers. So there's always going to be that kind of that different maturity level. So there's that as well. And then obviously it is dependent somewhat on the application. So if the application is, say, 15 years old or 20 years old, and it was written in .NET 1.1, you're probably going to run into a bit more headaches than you would with, say, a more modern application.
Very good. Yeah, please keep your questions coming in, folks. If you have any as you watch, and we'll try to cover any lingering questions from the previous episode at the start of the following one. So, um, I suppose now that we have branching strategies wrapped up and put to bed, we can call that one done. Let's move swiftly on to what is the best architecture. Let's like open another can of worms, and I suppose, what are we talking here? There's service oriented architecture, there's monoliths, there's microservices. Maybe a good starting point, if we start with two questions, maybe Steve, you could give us a quick what are those things? What are the key differences across them? And maybe then Bob, you can jump in from the perspective of, what should an organization or a team consider when they're choosing an architecture? What's the things that go into that? So over to you, Steve.
Yeah, so service-oriented architecture. This was an idea that definitely was the prevalent idea back in the early 2000s. And the idea was to work out pieces of your application that you could split out, make into a service. You could stick a team on that service, off you go. And we were talking about creating like a handful of services to support an application instead of having everything all in one place. If we do have everything all in one place, that's what we generally call a monolith. And monoliths kind of fell out of favor, so now we call them a majestic monolith if they're a well-designed version of that. And then microservices are where you try and create lots of small reusable pieces that maybe you're supporting many applications and they can kind of compose together different sets of services. So that's the kind of basic description of them all. We can probably work with those to start with.
So in terms of what's the best, we're always going to use our good old, just like my accounting teacher when I was in university. It depends. It's always going to depend on your particular use case. It's going to depend on the problems that you're looking to solve. Personally, I'm a fan of not necessarily microservices, and I'm definitely not a necessarily not necessarily a complete 100% microservices, nor do I believe that anything should be completely 100% a monolith. I don't think you should have anything that's that extreme end of the spectrum. I think you end up creating a bit more overhead. So really the question is, how much overhead do I want to have? What problems am I looking to solve? So let me qualify with that. I'm sure, Tony, if you clip it, you're gonna be like, "I'm not a fan of microservices." I'm like, "Oh my gosh." It's gonna get me in all kinds of trouble.
That's the clickbait we're after. Yes.
So anyway, so kind of, yeah, it's the way I kind of look at it a bit is, again, it comes back to the problem you're looking to solve. So if you have a lot of teams and you want them to be kind of distributed, self-sustaining, able to deploy independently, you're going to naturally start gravitating towards more of a microservice-based architecture. Then you're going to naturally start saying, how can we remove the dependencies along any sort of hard communications? Because typically most microservices that I've seen, at least the successful ones, are using some sort of message bus to handle the communication. And if you're not familiar with that, is essentially it's almost like an event-based architecture that you've kind of distributed across multiple applications. So a really good one that we use internally is for our payments and our cloud platform. So we have a payments service, drops a message into the message bus. Our cloud platform goes up. They paid for this. We're going to go ahead and spin up an instance. So you kind of respond to those types of events. So that naturally will kind of, you'll start seeing that type of communication and trying to solve those types of problems. However, they may not be the right approach for every single application, nor would it be the right approach for every single possible use case. A really good example is I worked on some software that we sold to customers, and it was a combination SaaS software as well as self-hosted software, just like Octopus Deploy, but it wasn't Octopus Deploy. And we started breaking it apart. We started looking at it, say, we're going to have this service, we're going to have this service, we're going to have this service, uh, starting to approach more of a microservice-based architecture. But then someone kindly pointed out of, well, how is your client's going to set this up? You're going to have all these instructions that they're going to have to do to follow in order for the thing to work because they want to be able to host it on their infrastructure. Okay, well, let's start pushing it back together to be more of a monolith. And honestly, I mean, it wasn't big enough to be called truly a monolith. It actually was a fairly small application that we just want to make even smaller. But at the same time, it was kind of it made a lot of sense of, hey, this is something we're going to be giving to our customers. We want to uh, minimize the amount of maintenance that's required upon this. And so let's start with a monolith and then appropriately break it apart where it makes sense, because any instructions that we have to provide, that's one extra thing that the customer has to do. So then we kind of run into the same thing with Octopus. This is why, Octopus Deploy is still a monolith, is because we have self-hosted customers. And we want to minimize the friction that is involved with maintaining it and updating it and doing everything along those lines. So again, that's that type of use case where a monolith might make sense. Whereas a microservice might make sense again when you have, hey, I have hundreds of teams and then we have thousands of applications, and we're willing to kind of have this type of communication between the two. And we want to make sure each of these teams are self-sufficient. They can deploy independently. They're not, beholden to anybody else in terms of how they do any of their work.
Yeah, I think the interesting thing is when you look at it, you're like, what one factor do I need to think about to make this decision? And actually, when you start thinking it through, there are many factors. It starts being like, oh, it's this and this. Oh, and you end up with this big web of things that all influence your decision. Um, I've often simplified it by and in terms of all architecture, by looking at the team that is working on the software and working out how to make it possible to subdivide the team so that they can all work independently. That for me is like the primary thing to look at. So I've worked on systems where it was a monolith initially, and then as the team grew, we start tripping over each other because we're all trying to change the same thing. And it makes sense to say, let's not all work in the same area, right? You might be able to say, well, this whole chunk over here is like the main system, but then we've got these integrations. They could be separate. We could move them out and we could have an integrations team who take care of those. And now you can have two teams, they're not tripping over each other and they don't depend on each other. And so if you kind of keep following that model where you're designing the teams first and then pulling the architecture into how those teams work, that can be quite successful. Um, I get quite worried when I hear about teams of, maybe there are two teams in the organization, but they have 300 microservices.
I was just thinking that. Yeah. I think that to me is a smell. And in fact, I worked on a team where we were trying to create these microservices, and I think there was 7 developers and we had over 20 services, and that felt like a lot because at any given point in time, I'm probably working on 2 or 3 or 4 different services that I end up having to change for, some story that's come through. And I'm like, it just felt like it feels like you divided it too much at that particular point in time.
Yeah, and all of them need their dependencies updating, and all of them need all kinds of things. You're multiplying a lot of other activities as well as the coding. So I think there's a relationship between the number of teams you have and the number of services you have. And if you have lots of teams and one monolith, you're going to probably get the pain at that end of the scale. And if you have a very small number of teams and lots of services, you get the pain on that end. It's a different pain, but you'll be on that scale. So if you're somewhere in the region of services is about the same size as the number of teams, you're likely to not get the two pains of being too far away. And I suppose we might say, instead of calling them microservices, we call them Mesco services. They're just the right size. Sometimes that might be a little bit bigger than what we might call a microservice, but that's fine if that's what matches your teams.
So I'm going to use a credit check service as a particular example. So I worked at a bank, and when you submitted a loan, we would check your credit. I mean, I think that makes sense. There's not any controversy around that. And so, but there are a couple of the other things that it would do besides just checking your credit. It would also cache the credit score. So for say 90 days. So if another person, if they applied for another loan, say they bought, because it was for farmers. So they did a land loan, and then they did a chattel loan. Because one right after another. Well, we shouldn't hit their credit twice. I mean, that seems a little insane. I mean, it's not going to like it's changed in the past 5 days. So it would do caching. It would allow us to. It provided a kind of like a lookup. It provided a whole bunch of other things. Now, the argument could be made in the world of microservices that, hey, you should probably split that service out. You should have just a service that just does the credit check, and that's all it does. And then you have another service that handles, say, the lookups. Then you had another service that kind of does some of the more back end stuff, and so on and so forth. But it was just one team that was kind of working on this, and this was amongst many other things that they had to worry about. And so what was the value add in splitting that up? And in reality, there wasn't a whole tremendous amount of value add when you had one team responsible for the entire application, and you're kind of split it up a bit too much. It's funny to me when you're Stephen, you're talking a little bit about first you organize the teams and then you kind of determine the services you want. So in a sense, you're almost saying that we should implement Conway's law.
Yeah, I think we have to believe in it and actually act on it, right? So I think it's called the inverse Conway maneuver, where you accept that Conway's law is a fact, and so you actually design the teams to then try and achieve the architecture that you want instead of drawing a diagram and asking the teams to do it. You have to actually architect the teams as much as you architect the application.
I mean, I could see that. I also kind of think about it in terms of, again, what you want the problems to be solved within a particular organization. Let's go back to the bank as an example. So there was one team that I was on, I was a lead dev on, that we were responsible for the loan origination system. So that's where the people, they would come in, they'd fill out the form, that would submit it off, and then do a whole bunch of other things. Well, originally, the loan origination system had the decision engine within it. But as time grew on, having a team manage the entire loan origination system plus a decision engine, that was just way too big. And so the organization said it makes more sense if we have a team focused on solving this particular problem. We need them to really think about how can we make the decision engine more flexible, make it much easier to iterate on, and any number of those different things. And so I do agree that yes, we need to have somewhat of the Conway's law, but I also think the organization has to kind of think about, okay, does it make sense to have a team focused on solving this problem and really focused on how we want to architect this? Because then at that point, then yes, it does make sense to kind of split it apart because you're seeing the pain points. And I mean, you see this internally within organizations as well. Uh, when I first started at Octopus Deploy, I was one of the first US based employees. And so I was handling a little bit of everything in the US. I was doing some sales calls, I was doing demos, I was processing like quotes, I was doing support. And so there's a little bit of time each day that I could devote to each of these different individual tasks. But then as time moved on and as we started scaling up, it just didn't make sense. We needed to have a dedicated team in the United States focused in on support, and they handled those types of requests because there are often times that there would be requests that would come through that I couldn't focus on 100% because I needed to do these other tasks. Same thing with application teams. We want you to solve this particular problem and really focus in on this one particular problem. Okay, we're going to split you out and you're going to kind of work on the applications to solve that. And we'd have to figure out how we're going to remove that from the main monolith. Because I'm willing to bet oftentimes the creation of these teams comes about from a monolith that's been written, early 2000s, that has been around for 25 years. That like, how can we kind of start solving some of these problems and start making it a better overall existence?
Yeah, it's funny actually. You've got my mind thinking that team topologies is super relevant here. That's a good tool set for working out team design. But it also made me think one of the interesting things is when we talk about a monolith, very often we do think about this kind of old system that hasn't really got strong design in it. And very often, I think microservices are chosen as like, let's solve this kind of spaghetti ball of mud type software that we've got, and let's move it to microservices because then it will be nicely loosely coupled. But actually, the skills you need to redesign your system to be loosely coupled are as relevant to leaving it as a monolith or moving it to microservices. You still need to think about that design. And I think quite a lot of people don't. They move to microservices with too much influence from the problematic design in the old code. And so all of the coupling remains effectively the same. So if you're going to move to microservices, it has to result in a loosely coupled architecture. Otherwise, it's a fail. And potentially, you could also redesign it in the same way within the monolith. And when you've done that, you can have many more people working in the monolith without tripping over each other because they're working in different areas. But you then don't have necessarily the coordination overhead of which services call which other services, and what's the dependency chain, and those things. So yeah, I think if your main motivation is to redesign because of the coupling in your architecture, actually you should probably start trying to solve that before you move to microservices.
Another good smell that indicates a problem in my mind, kind of what you said, is we've talked to customers like, okay, we've implemented microservices. Like, that's great. Super happy for you. When we deploy, they need to be deployed in a certain order. I'm like, that's you didn't really do microservices then. You just created a distributed monolith at that particular point in time. If you still have this tight coupling that this service has to be deployed to this version, otherwise this application will fail. That's probably a pretty big smell that you might not have solved, to your point, the actual architectural problems when they just brought the coupling along for the ride with the new system. Now all you've done is you've just added a tremendous amount of overhead of how are we going to handle this deployment? How are we going to do all of these things? And then we get even more fun questions of like, well, not every service changes all the time. So if the service doesn't change, well, you want to be able to check that, but then also go through. So we have a list of 100 services we want to deploy. You need to check which ones have changed or which ones haven't changed, and they have to be deployed in a specific order. And if they're not, then things will start failing. I'm like, that's probably a pretty big smell. Something's not quite right yet.
Yeah, and I think that's part of the discipline of building microservices, is thinking about compatibility as you make changes.
Yeah.
It's a little bit, if you've done a lot of database changes in the past, you've probably got the refactoring patterns from that you can apply. So, if you're going to add a new parameter, you're going to give that a default value, or make it optional so that you're not forcing everyone to upgrade, at the same time. I think that's kind of crucial to this. And speaking of databases, it's quite common to find microservice architectures, but a single database underneath all of them, which doesn't solve your scaling issues.
I have seen that, and I'm like, well, you've just it's basically I had 99 problems, and then I created 99 problems in one database, and then I created microservices, and now I have 100 problems in one database. So you just add it on top of that. That to me was probably one of the more wild scenarios I've seen kind of go through. And again, that's another indication. Unless you're willing to split apart the database, then having multiple microservices doesn't really make sense, because again, these have to be independent and deployable. It's fine if you have a database that's backing your microservices. We're not saying that. What we're saying is that as part of that migration effort to get to a microservice, that database section, those pieces, they need to be split out. Now, this introduces a really interesting question, and I ran into this again. And this also comes up with SOA-based architecture of what is the truth center, and then what if you need to have a copy of that data? Should you have that still in your system? So I'll go back to the loan origination system as a really good example. Within the loan, you have to put in contact information, the person's information, name, address, et cetera, et cetera. Should the loan have the contact information stored alongside it, or should we have the contact information from the customer service? How should that work? And so what we ended up deciding upon was you should have a copy for this particular use case, because that represents a point in time, whereas the customer service represents current state. And so we need to be able to kind of associate the two. But that was the decision we make. I'm still not saying it's the right decision, but that's the decision that we make. And so again, you kind of end up in those types of situations where you have kind of a subset of the data strewn throughout all of the other systems, which is it's another difficult problem to solve when you start, again, breaking apart the monolith and having a SOA-based architecture or microservice-based architecture.
Two questions that have come to mind for me as we sort of went through this. We've talked a little bit about the teams that are involved, and sort of abstractly the person or the team that sits above those teams and makes the decision around the architecture. Who is that person? Like, who is that team? What is the job title? And I'm sure that's probably controversial in itself. And the second question, we can sort of probably nail both of them. You've probably answered a little bit already, Bob, but from a deployment perspective, like pros and cons of both. You talked about some of the cons with microservices if they're sort of bumping into each other, but those are the two things that came to mind for me as we went through.
When it comes, it's funny, when it comes to the team, or it comes to that person that's kind of sitting above all of this, there's a couple of job titles that typically come out. So it might be something like principal engineer or principal architect. And there might be a couple of architects on a team where they're kind of setting the standards and setting all of those things. They do have to have a bit of authority, so they might also report directly up to like the senior person, be a director or a vice president of that particular organization, who has the authority to make these decisions to move people around and say this is how it's going to be, that type of stuff. Uh, Now, the downside of that approach is that it is very much, you're coming down from your ivory tower and saying, "This is how we're gonna organize everything, and everything will be perfect," and, uh, so it should be really collaborative in that particular sense where each team should have, either an architect or a principal engineer. Sometimes they're kind of combined into one where that's like a lead dev. They all kind of work together and have these discussions and have an open forum to make sure that everyone's opinion is heard and everyone's concern is dealt with on something along those lines. But yeah, it's always interesting when it comes down to it in terms of how you want to organize it. Again, the more people that you have, the more opinions you're going to have, and the more pushback you're going to get, and so that always makes things harder.
When it comes to the pros and cons of microservices, like I think when we talk about them, we can sound a little bit down on microservices because we're full of cautionary tales. That's only because excitement is currently for microservices. And so we're trying to counter that. Actually, I think we're quite microservice neutral. It is definitely the right choice for a whole bunch of people. It's definitely the wrong choice for a whole bunch of people. So I definitely don't want anyone to take away from this that microservices are bad. If they're loosely coupled, they can be great. When I moved house, the first time I did it, we got given a bunch of cardboard boxes because I worked somewhere that dealt with physical products, and we got these big boxes, and we filled them up and couldn't lift them. Right, they were just too big to lift. I've got a lot of books, and if you fill a giant box with books, it's actually not humanly liftable. So it was definitely the right thing for me to, the next time I moved, get small boxes that I could fill and lift. It was more journeys but far easier. And I think it's the same with microservices. If they are making something liftable in your organization, that's a good thing. That's what we want to get from them. But if you can pick up the box with everything in and do one journey, then that's good for those organizations. So definitely, if anyone's going to put a comment saying, isn't context important? This is the moment where context is super important. It definitely is here.
Yeah. And back to Steve's point, when you do microservices correctly, they're loosely coupled. The deployment advantage behind all of that is you can deploy when you're ready, like when your service is ready, it can be pushed out. And as long as, again, you have that loose coupling and you have the backwards compatibility, it's not going to really matter when you push that out. Even if you push out after something, a dependent service gets pushed out, again, because you have the loose coupling, and then because that service should be able to handle multiple versions as well. Oh, I got this message as opposed to this message for whatever reason. So independently deployable is probably the biggest thing to strive towards. Whatever architecture you go after. If you go after, if you have multiple monoliths, which kind of sounds insane, but I've seen it happen where there are multiple monoliths, each kind of represented in an org. As long as they're independently deployable, fantastic. To Steve's point, if you can lift everything up in one box, it's not that big of a headache. Doesn't cause a massive outage. Who am I to argue? It could also be written into your contract. It has to be done a certain way. But if you can have SOA-based architecture and everything's independently deployable, that's even better. Microservices, even better. In my mind, as long as they're independently deployable, that is the line in the sand.
Steve, question of the week. What have you got?
My question of the week this week is going to be, why are all of the events in Europe at the same time? They're all in March, and then there's like practically nothing for the rest of the year. And similarly, why are all of the North America events all in like November, and there's nothing else the rest of the year? Like, what is the difference between the Europe and the US that we choose the different end of the year?
I'm gonna guess it has to deal with the weather because typically springtime in Europe, I'm gonna go out on a limb and gonna say that it's probably a bit more temperate and a bit more predictable, whereas springtime in the United States is kind of like it could be really nice, it could be really windy, it could be snowing. When I was in university, it snowed in the middle of May in Salt Lake City, and it wasn't a lot of snow, but it was snow. Like it was a couple inches. So I'm going to go on a limb and I'm going to say it probably has to do with something with the weather.
It's actually a good theory, because I was sat here trying to work out if there was some kind of sporting event that we didn't want to clash with or something, but I couldn't think of one.
This is my theory that I put all of 30 seconds of thought into.
Those are the best theories.
I don't have a better one. So let's go with Bob's. Alrighty. Thank you, everybody. Until the next time, please remember, put your questions in if you have any. And yeah, we will see you next time around. Talk soon.
Have a good one, everyone.
Bye-bye.
Bye-bye.